This is going to be a pretty short video on how to simplify polynomial expressions using addition and subtraction. Okay, so I'm going to do about 2 to 3 examples. Let's look at the first one. We have 3x squared minus 2x plus x minus 1 plus 8x minus x squared plus 3. Okay, so when we're simplifying something like this, we need to kind of think about combining like terms. So in other words, everything that has the same type of variable next to it is going to go together. For example, this has an x squared, this one does not, this one doesn't either. I don't see another x squared until I get to this piece right here. And it's also really important to notice the sign in front of it. So I'm going to go ahead and underline the negative right here as well. Okay? So when we're combining these terms, we look at the coefficients. So in this case, I have a 3, and this one has, remember there's an imaginary 1 here, negative 1. Okay, so when I'm adding this, because that's the operation in the middle, I'm just going to add the numbers. So 3 minus 1 is just 2. And of course, I bring down my x squared with it. Okay? Once I combine something, I can cross it out and move on to the next term. Okay? So the next thing I see here is a negative 2x. I'm going to go ahead and circle this one. This is just a method I used to use with my Algebra 1 students. We put different shapes or different colors for the different terms. Okay, so this is minus 2x. I also see I have another x right here. So I'm going to circle this one as well. And I'm going to include the sign in front of it. So there's a plus here, and there's also an imaginary 1 here. Okay, minus 1 doesn't have an x. 8x does have an x, so I'm going to circle this one. And again, I'm going to include that positive sign right here. Okay, and 3 doesn't have anything. So for my green circles, I have negative 2. So negative 2 plus 1 plus 8. So for those of you who need the math on the side, I'm looking at negative 2 plus 1 plus 8, because those are the coefficients that go with this term right here, with this x. Okay, so negative 2 plus 1 is negative 1. Negative 1 plus 8 is just 7. So plus 7x. And now I can cross out these terms. Okay, my last term that I see here is this minus 1. So I'm going to go ahead and put a box around it. And these are the terms that have no variables next to it. So any number that's just by itself with no x or anything is going to go with this minus 1. So I also have a plus 3 over here. And again, make sure we include that sign that goes right in front of it. Okay, this is just negative 1 plus 3. Negative 1 plus 3 is positive 2. So plus 2. And this is my simplified polynomial expression from the example given. Okay, let's go ahead and look at a subtraction problem, and then I'm going to do 1 to 2 more. So here's the next one, and if you notice, here's my subtraction sign right here. Okay, this one does have a few more different types of variables. We have x to the 4th, and we don't have any x to the 3rds, but I mean we could have it. So maybe that'll be in the next example. Okay, so the first thing you need to do when it comes to subtraction, I'm going to kind of outline that here. When we're subtracting in a polynomial expression, people tend to forget that this minus is actually going to distribute to everything inside the parentheses, okay? Or the second term. In this case, everything in here. So the first thing I'm going to do is I'm going to rewrite this. So for subtraction, we need to rewrite. And if you need to write that down somewhere, write it down for your own notes, okay? So this is going to be negative x squared here. Negative times positive is also a negative, so minus 3x to the 4th. And then negative times positive again is a negative, so minus 7. So now that I've distributed, now I can bring everything else down. So I'm going to bring down my 10x to the 4th minus 3x squared plus 8 minus 2x. And now I can combine everything, okay? So again, before you try to combine anything in subtraction problems, make sure that you distribute that minus to everything on the right side of it, okay, in parentheses. I'm going to go ahead and start combining. So just like last time, I'm going to look for stuff that looks the same, okay? So I see that I have some x to the fourth. I'm going to underline all the x to the fourths. So here's one. Here's another one right here. Okay, and it looks like that might be it. Notice that I am keeping the sign in front of it as well. So I'm looking at the numbers. So in this case, 10 and minus 3. So 10 minus 3 is just 7. And of course, these are x to the fourth, so I have to bring that x to the fourth down with it. And I can cross it out. Okay, I'm going to look at the next thing that comes up. Looks like I have a minus 3x squared here. So this one has x squared. So I'm going to look for any other thing that has an x squared. It looks like I have one right here. So I'm going to circle this one as well because these are like terms. Negative 3, remember there's an imaginary 1 here. So negative 3 minus 1 is negative 4. So negative 4, and again, these are x squared. So I bring that x squared down. Again, I can cross these out next. And now I have a plus 8 right here. So I'm going to go ahead and box that up. And this one does not have a letter next to it, so I'm going to look for something that also doesn't have a letter next to it. This one has an x, so I can't combine it with that one. But this one doesn't have anything, so I could combine these two. Okay, so positive 8 minus 7. 8 minus 7 is just 1. So plus 1, positive 1. Okay. And the last thing I'm going to do that I see here is that minus 2x. And since it doesn't really have it, there's nothing else left. I'm pretty sure this is probably going to be by itself. But if there was another x, I could use maybe a triangle just to say all my triangles go together. There's no more x's, so this is by itself, minus 2x. Okay, so this right here is your answer. Okay, but you know how when it comes to math, there's always a technical way of doing things. In polynomials, we like to go from the greatest degree, so like x to the fourth, this would be your degree here, to the smallest degree. So we have x to the fourth, x to the x squared. This doesn't have anything, and this is like x to the 1. So we kind of have to rearrange some things here. Okay, so I'm going to rewrite this. 7x to the fourth, then the next one is a 2. So minus 4x to the power of 2. The 1 doesn't have anything, so I kind of skip it, go to this one, minus 2x, and then finally plus 1. And this is a little bit more correct. Okay. And that's pretty much it. We can do one more example just for the sake of practice. And let's do this one a little bit weird, just so you know what to do if this happens. Let's say we have x cubed minus x to the fifth plus 3x to the fourth minus 7, okay, minus, let's put in here x squared, we'll put 3x squared minus 3x to the fourth plus, I don't know, 9. Okay, and I'm completely making these up. So this is a subtraction problem. Okay, so just like the previous example, we need to distribute this first because that's our first step. We need to rewrite it. So this would be minus 3x squared. Negative times a negative is a positive, so plus 3x to the fourth, and then negative times positive is negative, so minus 9. Again, I'm just going to bring everything else down. X cubed minus x to the fifth plus 3x to the fourth minus 7. Okay. So again, I have to rewrite this because there's a subtraction. So that way I can avoid having to rewrite my answer. I'm going to go ahead and find the biggest degree first, so the biggest exponent. So it looks like it's going to be this 5 right here, this 5. And I'm going to start combining the ones that have anything to the 5th power first. That way, like in this example, I don't have to do this where I have to do another step. Okay? So it looks like this is the only power to the 5th. So I'm going to start with negative x to the 5th. And I can cross it out because there's nothing else I can combine it with. Okay? The next power that I see is this 4. So I'm going to take positive 3x to the 4th here and another positive 3x to the 4th here. What a coincidence. Okay? And again, I only look at the coefficient. So I look at the 3 and the 3 right here. So 3 plus 3 is 6. So plus 6 and then x to the 4th. And again, I'm going to cross it out once I'm done using it. Okay. If I look at the next degree, I have a 3 here, and that's the next one. So I'm going to go ahead and box up this x to the 3rd. And I don't have any other ones, so this one is by itself. Since there's nothing in front of it, it's automatically positive. So plus x to the 3rd power. Okay. After that, I have a 2 here, so I'm going to go ahead and let's see, what shape can I use? I'll just kind of do this little like squiggly thing. Okay, so I have minus 3x squared, and this one also does not have any kind of pair that goes with it, so it goes next, minus 3x squared. Okay, and I'm going to cross it out, to cross this one out. And finally, I'm left with my minus 7 and minus 9. So, you know, for the sake of keeping the shapes, let's do like a, I don't know, a longer box. I have negative 7 minus 9. So negative 7 minus 9 is minus 16. And I'm done. I've crossed out all my terms. So this right here is my final answer. And this is my simplified polynomial expression that's also written correctly in descending orders. In other words, 5, 4, 3, 2, and then, you know, so forth. There's no 1 because we don't have an x, but these need to be going down. Okay? And that's it.